Hi, so finally this is the lecture that clears up whatever mistakes that I did in the real life lecture that I did this Thursday afternoon. So thank you all for your patience. Once again, thank you for being there, and I hope this will help clarify any doubts, and I really sincerely apologize for it. So let's go look at the stuff one by one. So nothing major so far. The first issue we have will be on this slide. I clarified this in the break, after the break, but just to reiterate again, what this stores is that it stores the clusters based on the department. So computer science will be over here, and the faculty below it will be people that belong to the faculty of computer science. Next will be physics, and physics department is over here, and the people the faculty that belongs to the physics department will be over here. Those notice that for the faculty members, the department is missing. It is implicit to belong to computer science. I think I also shared in the lectures that you can also have a pointer over here which points to the various departments, and so if I have a query such as select staff from department, we will be able to use the pointer to easily find out all the department names from the table. So from the reason why we have this is why we have those pointers is that if you don't have those pointers, it's going to be very expensive to run this query. Okay, let's having cleared that up, let's go on. I think this all hopefully still okay. Okay, yeah, this is one thing that I missed. Actually, in the lectures this afternoon, I missed out on this point whereby this was ordered. So I incorrectly said that you should insert this in record 1. That should not be the case. You should be inserting this in record number 4 instead. And this pointer will then point to this directly. You delete all record number 2, you will have this pointer pointing to 1, 2, and then to 6. And after that, you insert this record. This will go to record 6. So you have a header points to record 1, record 2, and then to now. Okay, so this should be how the question is answered. Yeah, thank you for understanding. Let's go on. I think we're still fine for all this. Seems to be still okay. Yeah, so the diagram for BST was not correct. Actually, it was binary tree, but I think in the context of things, the BST will make more sense. So I changed it to a BST, so this will be better. Oh, I also realized that the B tree was wrong, so it was showing a B plus tree. So I changed this to a B tree now. Okay, this is still fine. I think everything up to now is still fine. The next very big screw up was this question. So I did initially, or rather I did think that we should have 200 here, but apparently yeah. So so maybe to put in the entire thing in context. So we have 100 million search key values, which means that my n is equals to 100 million, and my search key and my pointer consists of 12 bytes and 8 bytes together. So in total, my search key pair is 20 bytes, and we have the size of my node, which is 4K. So it actually means that for each of my node, I will have 200 pointers that are pointing out, which means that it's a 200. It is a B plus tree with 200 nodes that are pointing out. Okay, oh sorry, 200 branches that are pointing out. If you recall from your data structures, right, if for the height of a binary tree, it is log n base 2, And if you recall from if you have 3 branches, it will be log n base 3. So naturally, for this case, my initial thought was this should be log n, which is 100 million, base 200. But but they put in the number 100 there, so I believe there must be a reason. So upon thinking this through, I felt that they probably have the idea whereby for b plus 3 for this databases, the average case is that only 100 elements or 100 keys are being filled up by every node. And so on the average case basis, right, you have only 100 pointers that are pointing out. So in that case, that means that in every tree, the branching factor, the fan-out factor is going to be 100 instead of 200. And if we use that reasoning, then it will make sense whereby this will hence be a log n base 100, which is log 100 million base 100, which goes to the value of 4. And since by the rationale the root node is already in memory, we will only be left with 3 I/O operations of the node. Okay, so we cleared this up. Okay, so this one not much issue, I think. I hope. So I hope this one was not much issue. But maybe to reiterate this, you probably can say that it is very improbable that I'm going to get 2 clustering indexes that are arranged in the exact same way. Anyway, so it is not very probable that you're going to get 2 clustering indexes that are of the same order in the same table. So it's not possible, probable. Let's look at the next one. So I think this should be fine. Okay, so I hope I'm good. I hope I managed to resolve any of the unclarity that we have. And this is the feedback to help us to provide the feedback. Thank you so much for your time. Cheers.